Hi, this is Raphael Mudge, the creator of Cobalt Strike. Welcome to Part 5 of Red Team Operations with Cobalt Strike, Initial Access. The goal of this lecture is to help you deliver a weaponized file to a target and get them to open it so you can start to do post-exploitation. We will talk about the client-side attack initial access model. We will talk about spear phishing. We will talk about tradecraft around getting a weaponized file delivered to a target via email. And we will touch on the assume breach initial access model as well. What is an initial access? An initial access is your first compromised system in a target environment. It is patient zero. It is where you do post-exploitation from initially, and if your objectives require it, it's where you may escalate your privileges, where you may spread laterally from, and where you may pivot through. An initial access is where you start to work from your objectives. What is a client-side attack? A client-side attack is an attack where you get code execution by using a vulnerability or feature in a desktop application used to view attacker-controlled content. Why is client-side attack so interesting as an initial access model? Well, let's pretend hypothetically that I happen to have an amazing zero day and I can just point it at a target and get code execution on it. Great. Well, one of the problems we have in modern environments are firewalls. I, the attacker, am out here, and the target and targets like it are behind the firewall. So even if I have the most amazing zero day in the world that can hit any Windows system, let's assume it doesn't have a host-based firewall, I'm limited in my options because those systems are not available to me on the internet. I just can't reach them. So what is an enterprising attacker to do? Well, client-side attacks are a solution for an adversary who wants access to a network to work on their objectives. And the whole idea is weaponize a payload by combining it with something that's going to run it, like a client-side exploit or a user-driven attack, come up with a pretext, and package that pretext and your weaponized content into an email, send it to a target, and if they open it, congratulations, you get your initial access. You have your initial foothold. And now, if your objectives call for it, you can escalate privileges, find targets, and try to spread laterally. And that is the client-side attack initial access model. Here is the client-side attack process as I see it. The first step is to map the client-side attack surface. This is your open source intelligence gathering. This is any kind of active and passive reconnaissance you do. But the main idea is understand as much as you can about your target before you fire anything. Step 2. I recommend that you create a virtual machine informed by your reconnaissance for testing purposes. Use this virtual machine to try to select the best attack. And the best attack is very dependent on how much you know about the target and what kind of risks you're willing to take. For example, you might have an awesome attack, but it requires a very specific version of Adobe Flash paired with Internet Explorer 11. That's really specific. And if you happen to know that, hey, that's going to work, great. But if you don't, you may need to choose something more general. Once you've chosen what you're going to use as an attack option, Try to disguise the attack to match some sort of pretext. A pretext is the ruse or lie that you are using to get the recipient of your weaponized document to open it. So in step 4, you really want to give that consideration and try to come up with something plausible. In step 5, put it all together and send it off as an email to your target. And if all goes well, you will get an initial foothold into your target environment. Cobalt Strike has a few tools that can help out with this phase of your engagement. One of them is the System Profiler. The System Profiler is a client-side reconnaissance tool. It's a web application. So if you go to Attack's Web Drive-By System Profiler, you can configure this application. A few things I want to point out. The redirect URL is a website that any visitor will get sent to after they visit the System Profiler. I also recommend that you uncheck Use Java Applet to get information. Using an unsigned Java applet in a web application has no place in 2019. The results of the System Profiler are available in Cobalt Strike's data model. Go to View, Applications, and you will see a table with everything pulled from the System Profiler. Today, you can expect to pull the operating system, the browser, whether or not you're dealing with a 64-bit browser, and in very limited cases, the internal IP address of the target. If the visitor is using Internet Explorer, the JScript application is special interest because the last number, in this case 19203, happens to map to a build number for that DLL, and this can help you assess the patch level of the target system. Another interesting feature is the Website Clone tool. The Website Clone tool is a tool to disguise a web drive-by attack. If you go to Attack's Web Drive-By clone site, you can give it a URL, where within Cobalt Strike it should get hosted, and if you happen to have a web drive-by attack running in another framework, something like a browser exploit or a plugin exploit, you can embed that as an iframe using the attack field. Cobalt Strike's Website Clone tool also includes a simple JavaScript keylogger as well. The next step we're interested in is spear phishing. This is getting our weaponized package and pretext content to our target. Mechanically, here's how you spearfish with Cobalt Strike. Step 1, create a target list. A target list is just a flat text file with one email address per line. You also have the option to specify the first and last name of the target as well. Just separate the email address with a tab and then have the first and last name on the same line. That's all you have to do. Step 2, create a template. We'll talk about that in just a moment. Step 3, choose a mail server to send through. There's some nuance to this decision. We'll talk about that. Step 4, put all of it together and send the message. A spear phishing template in Cobalt Strike is simply a repurposed email. That's it. The trick is to export an email from your email client, save it to your local file system, and there you go. You can use that as a phishing template. And most email clients have a way to obtain the raw message content. For example, you can go to something like View Message Source if your email client has it. Sometimes it might be something like View Details and download original message. But either way, most email clients give you a way to pull this raw information. And here's what an email looks like. It includes headers and it includes your content, sometimes multiple variations of the same content, maybe a plain text and HTML variation. One thing with templates is that there are template tokens in Cobalt Strike. And if you add these to your templates, this is a way to customize each email that is sent by Cobalt Strike. %URL% is a URL that you want to embed into the email. _name is the name of the target. So Dear Bob Jones. And %2% is the email address of the target. Which mail server should you use? Here's our Cobalt Strike. And we have two options. First, we can stand up a local SMTP server and direct our email to that. Or we can use a cloud provider, a cloud email provider, that is hosting our phishing domain for us. And we can use that to send our phish. Let me explain what happens when you go this route. When you go this route, let's say I opt to send my phish via the local SMTP server. So Cobalt Strike will connect to it on port 25 and use a protocol called SMTP to say, hey, I have a message I want you to relay. And the local SMTP server will accept that message, and it will then look up a DNS record on our target domain to find out where the mail server is for that domain. And that DNS record is the MX record, or mail exchanger record. And our local SMTP server will then connect to our target domain's email infrastructure. So let me write that in and draw a little arrow of our local SMTP server connecting to that mail server and saying, hello, I have a message for you, here it is. The other option is that we can connect directly to our cloud provider's email infrastructure, and we can authenticate to it. And Cobalt Strike's phishing tool does have options to authenticate if you have credentials and want to go that route. And our cloud provider will look up the MX record for our target domain, and it will connect to our target domain's email server and say, hello, I have a message for so-and-so, here it is. When you go this route using your cloud provider, you have the benefit of having the message relayed from their SMTP server, which might be something that happens to have some trust because it belongs to this cloud provider. And that is a perfectly valid way to go. When you connect via your local SMTP server, you have a connection coming from you, okay? From your current system. If you're going to do that, what I recommend you do instead is that you skip this step. I recommend that you do not send a message via your local SMTP server, and you just skip that step altogether. And instead, I recommend that you look up the mail exchanger record of your target domain and direct Cobalt Strike to connect to it directly and relay your phish. And if you do that, it will be the same effect as having connected to a local mail server. So really, you have two options. You can use a cloud email provider, which makes absolute sense if you have a phishing domain and have all kinds of records to make your domain trustworthy. And if you're going to spoof a domain, you are just as well off to connect directly to your target domain's email infrastructure and use that as a mail server. All right, with all of that, the next step is to just send the message. Here is the Cobalt Strike Spear Phishing dialog. It is available under Attacks Spearphish. Just choose your targets file, pick your template. If you have a URL to embed, select that, put in your mail server. If you happen to have a more complex configuration, press the ... button and choose your bounce to address, and choose this very carefully because there are tradecraft implications to that value. We'll get to that. Press preview if you want to check the sanity of the message content and press send to fire it off. That's what it looks like to send a fish with Cobalt Strike. Let's send a fish. Here we are in Kali Linux. Step 1, we need a targets file. Let's come over to the terminal. We'll open up targets.txt and let's put one email address per line. So jimstevens@acme.com, whatahog@acme.com. I recommend that you take advantage of the opportunity to tab and put a name with each email address. This will allow Cobalt Strike to better customize the email. All right, so we've got our Jim Stevens and our whatahog targets list. Looks good to me. Now we need a template. Let's come over to my webmail, and you can see I have a secure message from the National Bank of Rafi. This is a fictitious bank, and it is a fictitious phishing pretext, but it is based on something real. A number of organizations I work with like to send these encrypted messages that require me to download an HTML file and open it locally. I refuse to do it, and those emails go ignored by me. I am not a fan of this. When I was doing research for this presentation, I actually found that this particular mechanism of secure email has been used as a real-world phishing pretext to deliver the trick bot. So I'm not the only one to think that this is a really bad idea. But organizations use it. So we're going to use it too. So we have our secure message from our fictitious National Bank of Rafi that wants us to download an HTML file. Great. Let's go to this little gear, show source, and here is our message file. We have our headers and we have the content. Let's right click, save page as, and we will call it template.txt. Press save. And let's go ahead and open up the template. So here's our template file. A couple of things I want to point out. The to portion will get updated for each email in our targets list. When you use the tab character and provide a name, Cobalt Strike can better generate a more plausible to field. The other thing, the date will get updated by Cobalt Strike. Any attachments that are here will get removed. And this message is fine for the most part. I do want to point out something though. If you do not change this from header, you are now in the business of spoofing an email address, and you are going to be spoofing a nationalbank.rafi domain. This has big tradecraft implications. We'll talk about that in a moment. But I want you to be aware when you have a phishing template, if you intend to spoof somebody, that's okay. But if you don't, you need to update this from header with the domain that you control. If we wanted to, we could customize this message with the tokens we talked about earlier, but I don't think there's anywhere we really need to do that. So I'm going to leave that for a moment. So now we've got our targets and we have our template. What do we need next? We need an attack, a weaponized document to attach to the email or link in the email itself. If we look at the original message, we can see that the call to action is to open the attachment message.html. Why don't we use a weaponized HTA file as our attachment and go from there? Let's come over to Cobalt Strike, go to Attacks, Packages, HTML Application. We'll do our HTTP beacon listener. We'll have it drop and run an executable. Why not? Press Generate. We will call it message.hta. And that's a good excuse to update our template. The template refers to message.html, but instead we want to direct them to open up our HTA. So let's search for message.html, and we'll change that in our template. And I think that's okay. Now let's go to attacks, spearfish, and let's populate this dialog. Let's grab the targets file, and you can see this is how it parses with Cobalt Strike, so we know it's okay. Let's grab our template file. Let's attach message.hta. If we wanted to replace the links in the file, we can. We can just choose an embed URL here, but we don't have to. We need a mail server. In this case, we're going to deliver the message directly to Acme's mail server. And that is 172.168.30.131 in my local lab. I've seen some people put URLs here. Don't do that. That's not what this field is for. If you want to configure something more complicated, press ... You can put in a username, password, and the type of connection. So that's okay to me. We need a bounce to address. Let's go ahead and use as a bounce to the same address that is the from in our phishing template. So let's go ahead and just grab that and put that in. I think that's okay. And let's hit preview. Here's the preview Cobalt Strike gives us. We can see the message in its raw format. We can see what a hypothetical to field looks like. And we can see the date. And there's all this other stuff going on that's all okay with me. If we go to the bottom, we can see our attached message.hta. We have a HTML preview. The HTML renderer in Java is terrible, but this is a good chance to look at the individual links and make sure you're comfortable with what the message looks like. If there were a plain text format of the message as well, this would show up here in this tab. Hit close. And I think we're ready to go. Let's hit send. And there we go. Our fish has been sent. Here we are on our Windows 10 target. And let's log in as the user Jim Stevens. And you can see we have a freshly sent fish. You can see the message is directed to Jim Stevens. It came just now. You can see this is an encrypted message and that we are being directed to open up message.hta. So let's go ahead and grab that, hit run. And yeah, we'll allow it. And let's go back to Cobalt Strike and see what happened. And here we are in Cobalt Strike, and you can see we live in message.exe as the user Jim Stevens. So that was a demonstration of how to get a foothold using a phishing attack with Cobalt Strike. All right, so far I've mechanically described phishing, but I haven't really talked too much to the tradecraft considerations. Getting a fish to a target today is much, much, much harder than it was in the past, especially if their email is hosted by a cloud provider. Here's what you have to contend with. First, you have to deal with much, much more aggressive spam filtering and just even a higher standard for a message to get accepted and relayed to an individual's inbox. And that's a reality even if you have a legitimate email that's not a phish. So you have to contend with that, and that is a problem. Because you are sending a weaponized file, you also have to worry about any kind of mail antivirus gateway. You have to worry about any kind of sandboxing technology that's going to try to open up your file and detonate anything attached to it. And you have to contend with something called DMARC, DKIM, and SPF. All of these things can affect whether or not your message will get delivered to your target. To explain the tradecraft side of email, it's very important to understand the individual components of the SMTP protocol. Earlier, I introduced the idea that when a mail server wants to relay a message to a mail server for a recipient's domain, it looks up the MX record for that domain and connects to that mail server. The protocol that these two servers speak is SMTP, the Simple Mail Transfer Protocol. Here is what the SMTP protocol looks like and what the components of this are. First, you connect to a mail server on port 25 and you introduce yourself. You say, "Hello, I am whatever.com." Next, you provide something called the envelope. You state a mail from line and a recipient to line. Very much like an envelope versus a message in the real world, what is in this envelope does not correspond to what is in the actual message necessarily. It's good tradecraft to make these things correspond. We're going to talk about that. But be aware that as is, with no protections, no logic, the SMTP protocol does not care about this aspect. So mail from is a line where you're stating, here's who the message is from. More importantly, the mail from line is also a bounce address. So if something goes wrong with this process and the mail server cannot deliver the message, it will generate something called a non-delivery notice. And where that notice will go is to that mail from line, that bounce address. Recipient 2 is the individual email address that this particular message is getting relayed to. So mail from, recipient 2 are the envelope. Now, inside of the envelope, right, inside of the message or email is our message, right? And that message is that raw email file that Cobalt Strike uses as a template, which includes the headers and the content and possibly the attachment encoded in different formats. To specify that, the SMTP client issues a data statement, sends everything, and then issues a single period and a quit message, and there you go. The entire message is now queued up over at that destination server, and it will do its thing. The big things I need you to understand, though, is that the envelope and the message are different things, and how these two correspond to each other can very much affect the success or failure of your delivery. Here is how the SMTP protocol maps to the spearphishing dialog in Cobalt Strike. The targets list is your recipient 2, that aspect of the envelope. The bounce to address is your mail from, and again, that is a key aspect of the envelope. The mail server line is the SMTP server Cobalt Strike will connect to. And the template that you add is the stuff that comes after the data directive. Now, with all of that out of the way, we can finally talk about tradecraft. Let's say you want to spoof a message and you want to spoof who it is from. I say spoofing from because I'm referring to spoofing the from header in the message content itself, because that is what the end user will see. Well, first, if you are going to spoof a domain, I recommend you connect directly to your target mail server. You can use the dig command to look up the mail exchanger record for it. I also recommend that you make sure that the from header matches the bounce to address you provide to Cobalt Strike. So make from and mail from in the envelope match. If they don't, some servers that do inspection of email, trying to classify it as spam or malicious or suspicious, they're going to see this discrepancy and react negatively to it. So be aware of that. But if you're going to spoof the envelope, you have some other problems to worry about. So you have to be aware of something called Sender Policy Framework. Sender Policy Framework is a way of restricting which mail servers are authorized to use a certain domain in their email envelopes. So when I connect to a mail server and I say, hey, mail from Rafi@whatever.com, the receiving mail server is going to look up a text record on my domain on whatever.com and look for something called an SPF record. And that SPF record is going to list which IP addresses or IP addresses ranges are allowed to use whatever.com as a mail from. And if this check fails, your spoofing is likely to get called out. So be aware that Sender Policy Framework can sink you right here if you're trying to spoof a domain. I would not spoof a domain that has a Sender Policy Framework record. Another anti-spoofing measure to be aware of is Domain Keys Identified Mail, or DKIM. Domain Keys Identified Mail is a standard where a mail server can sign a message in its content. And included in that signature is a way for the receiving mail server to look up a text record on the owner's domain and get the public key needed to verify that signed message. DKIM is something that's present or absent. The presence of it gives a message strength in terms of its authenticity. The absence does not necessarily mean anything by itself, but it can. And that's where DMARC comes in. And DMARC is Domain-Based Message Authentication, Reporting, and Conformance. DMARC is a way for a domain owner to announce to the world, hey world, when you get an email from my domain, expect an SPF record and expect a DKIM signature. And if you don't see these things, then you should take the following action. And sometimes that action is drop it. Other times it's forward the message back to us because something is broken in our email infrastructure and we want to fix it. But the point is DMARC is a way of telling other mail servers, here's what I opt into as a domain, and here's what I want you to do when those checks fail. And you can look up the DMARC record for a domain as well. Just do a dig for the text record _dmarc.domain.com. Whether you're spoofing or not, you still have to contend with any kind of filtering that's being done by your target's mail client and the email infrastructure they rely on. Here are a few tips. 1, domain age matters. If your domain is a few days old, a few weeks old, or maybe even a few months old, expect it to be penalized in terms of trustworthiness. When you send a message, I recommend that you think targeted about your targeted attacks. Consider sending your message to a single target or very few targets and address the target by their name. The more personal and plausible the message seems, the better the chance of getting through. I also recommend that you take advantage of the ability to specify the target's name in your target's file. That's the email tab name format. Doing this will make for a better to-header in your message content because Cobalt Strike can fill in the person's name as well as their email address. I mentioned this with regards to spoofing, but it does apply also for spam. The from header and mail from your bounce to address should match. I also recommend that you avoid any suspicious URLs, especially dotted quads. And a dotted quad is an IPv4 address. Never embed an IPv4 address without a domain as a URL into your email. And if you own your own phishing domain, I do recommend that you set up DKIM, SPF, and DMARC for it. These things, when they're present, can help give more credibility to your email infrastructure. Finally, I have a few tips for just not getting filtered. Don't attach something that's an obvious executable file. An exe or DLL is certainly an obvious executable file, but so would be a Java jar file, maybe an HTA, depending on the configuration of the target's email infrastructure. Just realize that some attachments automatically get more scrutiny and are automatically stripped or just not accepted. Also, be aware that most email infrastructure is going to have some sort of mail antivirus gateway to look at your attachments and determine if they are known bad according to that scanning engine. This lecture focuses a lot on phishing because that is part of the Cobalt Strike feature set. It's something the product can do. That's great. As a vendor, I imagine that a lot of my customers do assume breach engagements. An assume breach engagement is one where your initial access is white carded. You are not being tasked with figuring out how to get an initial access by finding someone who's going to click a link and putting together a believable attack package. Instead, the customer has questions about things that happen after the adversary gets in, questions about their detection and response capability, or maybe even different paths to get at their data or business processes. So for these engagements, I just want to talk to a few things. To get a foothold and take advantage of that white carded access, I recommend that you use anything that works for you. Don't worry about being fancy. I really like the scripted web delivery feature for this exact purpose. It's very convenient to just get a one-liner back and run it on a target and go from there. But if you need to get fancier just to get something going, go ahead and do it. One situation I do occasionally get questions about is a starting situation that resembles more of a traditional penetration test. And that's a situation where the assessor or end user of Cobalt Strike is on site in the customer's network, plugged in, and they might have credentials, but they don't have a foothold to use to start using Cobalt Strike with. They need that initial access. If you're in that situation, here's what I recommend that you do. Spin up a virtual machine, ideally Windows 7 without antivirus, run a beacon payload on it, and then use the tools in Cobalt Strike to spread laterally to a system that you have credentials to control. And you can do this. Cobalt Strike's offense model is such that everything happens through the beacon payload. And this is not on accident. The product is designed that way because its attack chain is assuming that you are a remote actor who ended up with a foothold through a client-side attack. And from this foothold, you're expected to be able to do everything. And Cobalt Strike is designed for this. In its offense model, everything goes through your beacon payload. All your scanning, lateral movement, everything. In this lecture, we talked about the client-side attack initial access model. That is pairing a weaponized file or link with a plausible pretext and using spear phishing to get it to a target to get initial access in an environment. We talked about spear phishing with Cobalt Strike, and I took you through tradecraft considerations getting that spear phishing email to your target in the first place. We also talked about assume breach, because all this stuff like knowing how to phish is something every red teamer should know how to do. I believe that. But when you don't need to phish and it doesn't need to be part of your engagement, it shouldn't be. And that's where assume breach comes in as well. This concludes part 5 of Red Team Operations with Cobalt Strike, Initial Access.